The Honorable Mr. The Honorable Mr. Muhammad Khairi, Bachelor of Engineering, Master of Engineering, Doctor of Philosophy, Associate of Department, Lecturer and Researcher at Sipil Infrastruktur Engineering ITS. The Honorable Dr. Masyitah Md Nujid from Universiti Teknologi Marawi UiTM Malaysia. The Honorable Mrs. Fitria Wahyuni, Bachelor of Engineering, Master of Engineering, Lecturer and Researcher in the Laboratorium of Transportation and Geotechnical Engineering at Sipil Infrastruktur Engineering ITS. And the Honorable Lecturer and Alumni and Participant of webinar series in this morning. Alhamdulillah, first of all, let's say thanks to God who has been giving us guidance, happiness, healthy, and mercy, so we can attend and participate in this event without any obstacle, even though this event must be held by online. Before that, let me introduce myself. My name is Ainda Indraswari. As the Master of Ceremony, we will host webinar this morning. This event is the 14th webinar of series in Sipil Infrastruktur Engineering Webinar Series 2021. This 14th webinar series is about the topic of sustainable geotechnical infrastructure project in Malaysia. Ladies and gentlemen, on this next occasion, let me deliver the structure of the event today as follows. First, opening. Second, sing Indonesia Raya and DTIS theme song. Third, opening speech from Mr. Muhammad Khairi, Bachelor of Engineering, Master of Engineering, and Doctor of Philosophy. Fourth, reciting prayer with main lecture from the speakers followed by discussion, question and answer session led by Moderator. Sixth, certificate submission session and closing. Before going to the next session, webinar participants who have not filled in attendance can fill in the attendance first, where the link is in the Zoom chat. Entering the next agenda, singing the song Indonesia Raya and the DTIS themes. The audience is asked to string the seat and mute the mic so that they can sing the Indonesian national anthem solemnly. The committee on duty is welcome. Okay, thank you for the committee. Next agenda is opening speech. The speech will be delivered by us, Mr. Muhammad Hoiri, Bachelor of Engineering, Master of Engineering, Doctor of Philosophy. For Mr. Hoiri, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, Dr. Masyitah Md Nujid. Thank you very much. Thank you very much for joining our webinar, Civil Infrastructure Engineering, provide annual webinar in start from 2020 until now. And we try to invite international speaker in 2021. So for the future, we can use this event for beginning in our collaboration, especially between Universiti Teknologi of Manyar, UiTM, and ITS, especially maybe in geotechnical topic. Yeah. You already meet with Fitria Wahyuni, maybe one of our future researcher in Malaysia, maybe. I hope so. And so we hope in this morning you can sharing your knowledge about geotechnical topic to our students and also give them a new experience of Indonesian thinking, maybe like something like that. And I hope maybe some of us ini participant not very good in English. I hope they can ask also in bahasa in Malay language, because we still in satu rumpun in bahasa. We can still understand each other. Okay, I think that's all, and thank you for the joining. Also, some of lecturer here, also participant for our student, and graduate student, also undergraduate student. Some of graduate student also here. I look in at the participant list. Okay, thank you very much for Dr. Masyitah and all other participants. Let's enjoy this event and in this webinar. Assalamualaikum, waalaikumsalam, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for Mr. Muhammad Hoiri for the speech. Next agenda is reciting prayer. For Sultan Ilham, time is yours.
Okay, assalamualaikum. Oh, sorry.
Okay, thank you for the time. Before we start our webinar today, let's pray together. This time I will pray in my religion, that was Muslim. For the participant that non-Muslim, let's pray with your religion. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. Ya Allah, most forgiving our sins, the sins our parents, our teacher, Mr. and Mrs., sins and the sins of our national heroes who has fallen for us. O God, the merciful, give us health, intelligence, guidance, and protection in the studies, so that someday we can useful for religion and homeland. Ya Allah, the Almighty, grant to us all the science, the benefits, more blessing, and save us from all danger and desire. Ya Allah, the Most Wise, only unto the way do we really, and unto they ask for help, then graciously prayer and supplication of the servant this week. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin. Walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Sultan Ilham has recited the prayer. May Allah bless us. Amen. Before going to the next session, webinar participants who have not filled in attendance can fill in the attendance first, where the link is in the Zoom chat. Before entering the main event of today's webinar, let's take a photo for the audience. You may be able to on-cam first, and for the community, we can help with the communication. Okay. Here we have 4 slides. So, well, take a photo per slide. We're going to start with the first slide. One, two, three. For the second slide, 1, 2, 3. Okay, finished. Thank you for the committee and duty for helping us to take the presentation. Next agenda is the main of the event. Presentation from speakers followed by discussion, question and answer. Moderators on this webinar will be held by the Honorable Mrs. Fitria Wahyuni, Bachelor of Engineering, Bachelor of Engineering. For Mrs. Fitria, and is yours.
Thank you, Ayunda, for the time. And now, good morning, everyone, and thank you all for finding time and visiting our webinar today. My name is Fitria Wahyuni, and I'm a lecturer in Civil Infrastructure Engineering Department. A very warm welcome to all, and it's a wonderful day, and I feel so privileged to extend my warm to welcome all that presented here. But first, the Honorable of our Chief Department, Mr. Muhammad Khairi PhD, and our Secretary Department, Mrs. Amalia Mawadi, and Head of Hydrotechnic and Surveying Laboratory, Mrs. Camelia, and also our beloved lecturers in Civil Infrastructure Engineering, and also all participants. Okay, before we going to the main webinar, just a little housekeeping before we get started. Okay, if you have any question during the presentation, please type them into the chat box. I'll bring them up during the presentation if necessary, or we will also have time for question at the end of the presentation. To keep the quality of sound functional during the meeting, please mute yourself when you are not sharing, and I might also mute the room if necessary. But please remember to unmute when you wish to share or want to ask, or you can raise your hand feature in the Zoom feature to use raise your hand if you want to ask about the end of presentation. Okay, now without any further, we will turn the time over to our presenter. Okay, I will have some resume about our presenter today. Okay, our presenter today is Dr. Masyitah Md Nujid. She is a senior lecturer in the School of Civil Engineering from Universiti Teknologi Mara or UiTM in Cawangan, Pulau Pinang. She graduated in the Bachelor of Civil Engineering from Universiti Teknologi Malaysia or UiTM in 2005 and obtained a master degree in Geoteknik from Universiti Teknologi Malaysia or UiTM in 2007. And recently, now she has taught the soil mechanic and geotechnic course as well as the conducted research in the same field. She has published about 24 research article in the area and appointment as a peer-reviewed journals. Her research are interested in soil mechanics, computer modeling, and simulation, constructive soil model, and soil stabilization. You can see in my presentation about her interest in geotechnical engineering. Now, due to her expertise and experience, she has been appointed as an external examiner, judge in competition, a viewer of journal and conference proceeding, and a member of international conference committee from local organization. Now, please welcome to our speaker today, Mrs. Masyitah, Dr. Miss Masyitah Nujid. Time is yours, Doctor.
Thank you. Okay, Assalamualaikum and good morning. So I'm Masyitah Md Nujid, a senior lecturer from UiTM Cawangan Pulau Pinang. Today I'm going to present on the title Sustainable Geotechnical Infrastructure Project Malaysia, which is in the soil improvement and soil reinforcement. Actually, when you look at to this one, it's commonly bring the same applications and also the techniques, methods that can be applied on every geotechnical applications. So bila you lihat kepada keseluruhan pembentangan saya, anda akan melihat okay, soil improvement dengan soil reinforcement ni apa beza? Kadang tu dia boleh datang bersama. So bila kita nak buat reinforcement, kita kena improvekan dulu soil properties. Somehow when we dealing dengan soil characteristic, soil behavior, we can't have that soil in a good conditions. Ada masa tu site location kita ni bukanlah dalam keadaan baik. Dia bukanlah menunjukkan sifat dia yang baik kan. So kadang tu we have to treat them. Kita kena baik pulih tanah tersebut sebelum kita boleh mulakan apa-apa kerja pembinaan. So that's why I said here, bila kita buat satu application geotechnical engineering tu, they can come together, improvement dan juga reinforcement. Tapi untuk pembentangan pagi ni, saya akan tunjukkan dari segi definisi perbezaan dia di mana keseluruhan kita boleh guna kedua-dua kaedah ni untuk critical case. Contoh macam saya sebut tadi lah. Kalau kita berurusan dengan hilly slope tu contohnya hilly slope yang tanah ataupun batuan dia yang jenis sedimentary rocks yang bukan granite. Kemudian tanah rock tu pula telah di-weathered, weathering happen. So dia punya proses weathering tu menyebabkan the rock properties reduce. So sebelum kita nak buat cut slope ke whatever on type of any rock or soil, kita kena improvekan dia, barulah kita boleh letak reinforcement. So kalau kata anyone, siapa-siapa daripada ITS sendiri pernah hadir ke Malaysia, you akan tengok banyak kawasan di bandar raya lah, contohnya Kuala Lumpur, kawasan-kawasan highway, cerun-cerun dia semua telah di-improve dan juga telah di-reinforce daripada mengalami sebarang failure. Okay, forgot to say welcome and thank you for having me this morning daripada Civil Infrastructure Engineering ITS, all the committee members, also the participants, student, alumni, postgraduate and undergraduate. Okay, before we go further, I would like to ask you about this one. Okay, how are you feeling today? So, can you respond me by having by joining the class point, class code 73499. So you boleh scan QR code bar di sini menggunakan komputer, menggunakan kamera barcode lah. So kalau kata ada siapa yang boleh join class code ni untuk saya tengok. Are you feeling well this morning? Are you happy? Are you sad? Or you blur? Tak tahu apa benda kan kita nak sembang pagi ni. So mungkin boleh join dulu sementara. Oh good, welcome Alia. Alright. Okay, you may you may show me what's your feeling this morning. Okay, kita ada 4 participants. So I try to have engagement from all participants. So saya tak naklah rasa macam cakap seorang kan. Okay, thank you. Okay, kita dah ada 5 participants. So those who has joined this class point 73499 code dia, you can express your feeling this morning. Are you feeling well? Are you sad? Are you feel that you are joining this online webinar for nothing, or you are purposely aim to know what's exactly geotechnical engineering, and then how we can make the geotechnical constructions application in sustainable activities, for example. How are we going to do that? The activities in order to sustain our environment, our world from any pollutions. Okay, now we have 17 participants. Okay, those who have joined, you can click the answer. What is your feeling this morning? Are you feeling good? Okay, Alhamdulillah. 9 out of okay, 9 of students or 9 of participants say good. Okay, sad. All right. 2 of the participants are sad. Never mind. I hope that this program will be beneficial for every one of you. So we have 17 participants. Okay. Can you see this graph? A for sad, B for happy. I hope every one of you enjoy. As I said lah, this one supposed to be engagement between me and the participants. No forcing. If you feel that you want to answer, it's okay. If you don't feel like to answer, never mind. We still carry on the webinar. Okay, another few seconds before I stop the submissions. Okay, so we have around 20 participants, 17 says they are happy. So I hope that you are really enjoyed the webinar sessions this morning. Okay, what's exactly my topic this morning? I actually have arranged around 5 topics. For the first one is on overview geotechnical engineering. What I want to share is that I try to make all the participants fall in love in geotechnical engineering, because as you remember, when we dealing with any structure lah, apa-apa yang kita buat berurusan dengan struktur pembangunan, dia akan bermula dengan geoteknik, kerja-kerja geoteknik. You tengoklah, kalau you tengok high-rise building kan, yang 3-4 tingkat ke ataupun berpuluh tingkat, dia mesti mula dengan geoteknik. Kalau kata you minat dalam structural engineering, tapi you tolak bulat-bulat geotechnical engineering, hati tu tak ada, dia tak jadi, bangunan tu tak hidup. Kemudian sebagai engineer, dia punya tanggungjawab tu besar, bukan setakat masa you design, bukan setakat you bina. Selepas digunakan, the lifespan along the structure itself, dengan harapan kita doa bangunan tu selamat, tak runtuh kan. So maknanya kat situ, bila you kenal geoteknik, you kenal semua apa yang ada sekitar geoteknik, insyaAllah you are going to be happy with the things what you are doing. Okay, dalam topik 2 saya akan ceritalah sedikit peranan geotechnical engineer ataupun apa yang geotechnical engineer ni perlu ada. Dan saya tahu kebanyakan students yang ambil soil mekanik pagi ni, yang ambil foundations engineering, kemudian student daripada postgraduate, undergrad, memang dah tahu. Cuma kita nak lebihkan lagi, buka minda. Sebenarnya geotechnical ni bukan cerita pasal piling sahaja. Dia bukan cerita pasal shallow foundations. dia cerita banyak lagi applications, banyak lagi job opportunities that yang mana you boleh masuk dalam international area ataupun local area, for example in Indonesia. You can be a good contractor. You also can be a good consultant. You also can be a good engineer. Tapi macam saya bagi tahulah, I am encouraging students, participants to fall in love with the geotechnical as I did for my students. I told them you kena faham dulu geotechnical engineering tu apa benda, area dia, baru you akan rasa lebih suka, sebab kita akan menempuh satu syllabus, satu semester yang panjang, luas dia punya scope. Kemudian topik 3 saya akan explain on sedikit lah SDG 9 dan juga SDG 11. Rasanya ITS memang dah familiar about the SDG. So we have around 17 goals dan pagi ni saya diamanahkan untuk selit sedikit 2 goals daripada 17 goals. So goals ni mana-mana country selagi mana tertakluk bawah United Nations, kita ke arah sustainable development goal. Whatever you like it or not, you have to relate macam mana all the construction projects, activities, kita nak sustainkan dia. The sustain can be looking from different aspects. Contohnya kita boleh tengok dari segi economical aspect, kita boleh tengok dari segi social aspect, kita boleh tengok dari segi environment aspect. So 3 elemen ni penting supaya bila kita buat satu project, dia tak memberi adverse effect kepada environment. Dia juga memberi keuntungan kepada social, communities sekitar kawasan projek tersebut. Itulah yang saya cuba terapkan sedikit pagi ni. Kemudian topik 4 is our topik Sustainable Geotechnical Infrastructure Projects in Malaysia. Yang ni saya will explain on selected cases sahaja, and the last topic will be challenges. Challenges is very short one lah, because I try to summary up everything that I have explained in the all slides. Okay. And then the next one is that okay, the next one is on introductions. As I explained earlier, geotechnical sustainable infrastructure construction projects under Sustainable Development Goals 9 and 11 become important aspect nowadays. Because bila kita tengok keseluruhan negara, hold on for seconds. Sorry for these interruptions. Okay, when you look at to sustainable, what I said is now we couldn't avoid any development in whatever countries. When you go to Malaysia, for example, we can see there's so many high-rise building just due to COVID in the last 2 years. In the current year situations, the economy going down, and then the construction project getting slower. But as I said, you couldn't avoid any development in the infrastructure, for example. Sebab tujuan utama bila kita buat pembangunan, kita nak bagi satu kemudahan, satu fasiliti yang boleh menyenangkan rakyat negara tersebut. Contohnya lah, pada masa yang sama, kita juga perlu mengambil kira aspek-aspek ekonomi, aspek-aspek environment lah contohnya. Sebab ada environmentalist lah, for example, dia aktivis ni, dia akan kata, I don't like the constructions, I don't like all the development activities because they will give adverse effect to environment. Dia akan berlakunya air pollution, dia akan menyebabkan water pollution. But we can avoid all those environmental or pollutions effect dengan ada kaedah dia. Contohnya kita lihat dari segi design, contohnya ada tak design A dengan design B, mana yang boleh mengurangkan kesan carbon dioxide, contohnya penghasilan carbon dioksida, atau kaedah A dengan kaedah B, mana yang boleh menjimatkan earth material, filling material. So kita tak perlu potong cerun, kita tak perlu ambil tanah dari mana-mana kawasan. So we can do on site in order to improve the soil's properties ataupun soil behavior. This is the set that bila kita look at throughout the aspect, we can ensure that our construction project is sustainable. kita dah tengok dah keseluruhan aspek. Sebab kalau dulu kita tengok construction, we don't care much about the construction waste. Habis je construction, material yang terbuang tu dibiarkan dekat dump site area. So it's not good practice. So macam mana kita nak jadikan from the previous past experience practice in the current practice yang mengambil kira aspek SDG. Contohnya SDG 9 dan juga SDG 11. So again, when you look at closely, the sustainability we look at in the three aspect, environmental, social dan juga ekonomi. So bila ada pembangunan, kita tak nak mengetepikan sebahagian pihak, kita tak nak mengetepikan sebahagian community. Kita nak pembangunan yang kita buat tu memberi impak kepada masyarakat sekeliling kita, memberi impak kepada negara, memberi kesan yang positif juga kepada environment. Environment is something that yelah, environment kan, they cannot be then they have someone to spoken out what's the impact of the pollution contohnya, so that these activists lah yang memainkan peranan. Kalau kata kawasan pembinaan di cerun area, kita kena tengok apa kesannya kepada air, sumber air. Sumber air kita akan tercemar ke tidak? Kalau kata kita nak buat juga kawasan pembangunan di kawasan cerun area, kita kena ada mitigation plan, how to monitor all this after construction been done. Kalau kata mitigation tu berapa lama, monitoring, semua benda-benda tu yang kita perlu ambil kira bila kita merancang untuk buat pembangunan. When you become an engineer lah, sama ada structural engineer ke geotechnical engineer kan, kita nak lihat engineer yang bukan bersifat kapitalis, yang money oriented. Kita kalau boleh kita menghasilkan engineer yang melihat keseluruhan aspek tersebut lah. So this is the goals that we aim from these activities. Okay, now I go to topic 1. This is about overview geotechnical engineering. Okay, dalam geotechnical engineering we couldn't avoid that geotechnical engineering ni dia melibatkan beberapa branches dalam civil engineering itu sendiri. Contohnya bila kita nak buat satu dam, empangan air itu, memanglah kita tengok dia punya characteristic properties untuk building tu adalah concrete contohnya, kemudian water, and then don't forget about the geotechnical aspect, because this is the foundation base. Kalau you construct any structure without a strong base, any structure tu dia akan mengalami collapse, dia akan mengalami failure. Current practice kan, kalau you tengoklah sekarang kan, sebabkan kita dah limited open area, tanah terhad. Jadi option yang kita ada, contohnya kita buat tunneling. Tunneling pun satu kaedah yang mana kita tak perlu cut slope, kita tak perlu natural slope turn to cut slope. So kat situ kita dah sustain dia punya environment impact, because kita guna alternative. We have to think out apa lagi option yang ada. Contohnya sekarang transportation dia boleh berada atas jalan, dia boleh menggunakan light mass rapid transit, for example, kita ada LRT, kita ada MRT. So these are the options yang mana transportations ni dia ada kaitan juga dengan geotechnical engineering, because as I said, geotechnical engineering ni kalau you nak faham asas dia adalah foundation kepada mana-mana struktur, mana-mana application dalam civil engineering yang you akan bina ataupun you akan guna sama. Okay, selain daripada tu, bila kita tengok construction engineering, we have a ground structure, excavation, soil improvement, earthwork. Look at in Malaysia lah, contohnya di Kuala Lumpur, we have a new site area surrounded by buildings, and then the building ni memang dah existing, sedia ada guna. How are we going to construct a new building in the middle of existing building left and right? So the other way is that kita kena menggunakan satu material yang mana kita panggil dia sebagai sheet pile. Sheet pile tu dia melibatkan earthwork activity contohnya, ataupun you have a new site area, you kena buatlah some sort of activity earthwork. And then ada tu kita kena buat macam back to my previous case, example yang kita buat pembinaan dekat kawasan yang sedia ada. Kat situ akan ada ground structure. Dekat ground structure ni dia can be a ground basement, kat situlah kita nak letak car park. Kemudian daripada ground level tu barulah kita akan naik beberapa tingkat. But as I said, dia punya constraint kat situ, kalau you tak faham geotechnical aspect, contohnya soil behavior, you tak tahu what kind of the retaining wall yang suitable to be used untuk ground structure activity, then you don't know what type piling yang sesuai untuk tanah tersebut, dia akan jadi mess up lah. Dia akan delay time, dia akan affect the cost of the project, duration semua akan lari. So this is the overview yang mana bila you buat geotechnical project, you have to think out dia punya ni ada tak kaitan dengan yang ni. So environmental engineering for example, sekarang ni bila kita tengok the area of the branches untuk geotechnical engineering, dia dah expand kepada geoenvironmental. Geoenvironmental for example, look at to the landfill area. You tengok kepada kawasan tapak pelupusan sampah. Ada yang open dumping, ada yang closed dumping. Yang kalau kata problem yang selalunya licit ni dekat kawasan open dumping. Apa efek dia? Adalah groundwater table. Sebab ada setengah daripada landfill ni dia akan air tu akan masuk ke dalam kawasan tanah antara partikel-partikel soil tersebut. So bila kata dia masuk dan infiltrate kepada zarah tanah tersebut dan bawa kepada ground ataupun catchment area, water catchment area, dia akan memberikan kesan kepada pencemaran, water pollution. Water pollution ni nanti bila you nak guna semula untuk drinking water, you have to treat the waters before having for drinking. So itulah aspeknya bila geotechnical engineering expand to the geoenvironmental, dia akan melihat semua kesan ni. Macam mana kita nak pakai marine clay liner yang good, impermeable, yang mana dia tak boleh telap air. So dekat kawasan landfill tu, sebelum kita construct landfill, kita akan letak satu impermeable layer, satu liner yang mana bila air sampah tu terhasil, dia tak akan masuk ke dalam permukaan tanah ataupun air bumi. Air bumi itulah penting untuk sumber minuman ataupun any other applications. So selain daripada tu, if you look at currently for the last 2015 for example kan, we had the in Malaysia itself, in Sabah, ada earthquake. Sebelum ni kita hanya dengar okay earthquake in Philippines, Indonesia. But then bila dah ada geotechnical, bila dah ada earthquake impact ni, we have to look at the seismic parameters, and then we have to look at the accelerations of the earthquake, dia punya vibration tu berapa dia punya impact. Adakah high amplitude memberi impact kepada deformations of the structure or the failure. So benda-benda tu kita luaskan dia punya kajian, dia boleh pergi kepada earthquake engineering. Other than that, as I said lah, bila dia pergi kepada dam, kemudian groundwater drainage, marine geotechnic, so yang ni adalah berkaitan dengan hydraulic engineering. The next one adalah mechanical engineering. Mechanical engineering, as I said earlier, contohnya kita nak buat bangunan dekat kawasan cerun ni, kita kena tahu juga rock properties. Sebab rock properties ni adalah the parent material before turn to soil. So sebelum dia bertukar kepada tanah, batu ni mengalami lulu hawa. Dia dah mengalami degradations, weathering effect. Weathering effect can be due to wind, due to water, due to some sort any other things, contohnya salji kan, cuma dekat Malaysia tak adalah, tapi yang selalu berlaku lulu hawa tu boleh disebabkan oleh kesan-kesan air tadi itulah. So bila batu yang asalnya kuat tapi telah mengalami weathering, dia menyebabkan batu tu lemah. So sebelum kita nak buat cut slope, we have to understand the rock behavior, rock properties. Rock ni grade apa? Kemudian you nak buat cut slope ni, apa kategori of the rock material tu? Adakah dia igneous rock? Atau dia adalah sedimentary rock? Adakah dia metamorphic rock? So setiap tiga major parent rock ni memberi kelainan dari segi tekstur dia, dari segi dia punya the color of the rock itself. If you look at antara granite, sedimentary dengan metamorphic, they are memang totally different. So if you open the book lah kalau kata you faham lah granite ni dia boleh terhasil daripada magma. Manakala sedimentary rock ni selalunya kita akan nampak di kawasan oceanic ataupun kawasan sungai. So dekat dari segi dia punya lapisan layer tu kita boleh nampak kalau ada batu yang menunjukkan few layers that's a sample of the soil tu terhasil daripada sedimentary rock. Itu adalah something that we relate antara rock mechanics dengan geotechnical engineering. Macam mana the branches of this area they relates balik kepada understanding our knowledge in the geotechnical engineering. So geology dengan mechanical engineering ni the same thing that I explain lah, cumanya bila you relate dengan geology ni kita nak melihat kepada geomaterial yang bersifat dari segi size dia berbeza sedikit lah, and then the impact of the hazards tu. If you look currently few weeks ago lah in Malaysia, one recreational area has been flooded. So bila dia dah mengalami banjir kat situ, our rock kawasan tu adalah kawasan batu lah yang memang cantik. Tapi selepas dia mengalami malapetaka disebabkan banjir, so the all geologists came down and look at to what was the causes to the failure. So some experts say that due to the kepala air yang turun pada ketika hujan lebat tu menyebabkan berlakunya runtuhan batu tersebut. So bila berlakunya runtuhan batu ni, dia akan investigate pula what are other causes, factors yang menghasilkan kepada failure of this kind of rock. Sebab bila kita faham rock sebenarnya dia sesuatu yang lebih properties dia lagi stronger compared to soil. So how possible batu yang kuat macam ni boleh kalah dengan kesan air lah, that's I mean. So these are the things that we have to look at closely lah bila you memilih satu area yang you minat untuk you belajar lah dalam geotechnical engineering for example. Okay, apa peranan anda sebagai geotechnical engineer? Okay, ini yang kita nak tengok. Tadi kita dah tengok dah branches dia. Okay, antara peranan dia, sebelum kita nak pergi ke peranan, kita kena tengok apa dia punya applications, cabang-cabang yang kita boleh work in that. Contohnya, as I said earlier, kita ada natural slope, kita ada terrain slope, tapi bila ada water effect, dia menyebabkan instability. So, as a geotechnical engineer, what are the things that you need to think out, or whatever design that you need to propose to ensure the stability of the natural slope, for example, ataupun cut slope. Kalau kata daripada natural slope tu, you turn to cut slope, what will be the best angle for the cut slope to sustain daripada failure? So yang ni yang kita kena tengok. Is it tree berms enough to avoid any failure to occur, ataupun kita nak provide drainage, atau kita kena letak vegetations. So vegetations tu antara root strengthening to ensure that ada some element of reinforcement, soil reinforcement. So kalau you perasan mana-mana slope yang dah dipotong, dah diubah daripada natural slope kepada cut slope, lastly dia akan tanam rumput. So in Malaysia kita panggil rumput lah, so vegetation. So tujuan dia selain daripada aesthetic value, kita nak bagi satu sifat semula jadi kepada cerun tu, ada satu kekuatan dari segi dia punya reinforcement lah, supaya apa-apa berlaku particles antara soil tu dia boleh terikat due to the akar yang ada pada rumput tersebut. So kalau you tengok you Google daripada aspek of the study dah lama, dalam 15 tahun lepas lah, memang orang dah study the effect of root strength kepada soil behavior ni, especially untuk cut slope lah. Kita nak tengok sejauh mana, sebab we are talking about sustainable ni, kita nak cerita pasal sustainable. Pada masa yang sama kita nak buat bangunan ataupun kita nak provide facility kepada community yang dia sustain daripada any adverse effect. So mana kesan-kesan buruk kan. So kita kena think out lah kan, apa cara lain. So orang pun study pasal kesan akar rumput. Adakah kesan akar rumput ni memberi kekuatan tambahan kepada cerun, permukaan cerun tersebut. Kalau kata ya, nak kena tahu pula kan rumput jenis apa, rumput A ke, rumput B kan. So benda-benda tu yang you kena lihat lah lebih. So selain daripada tu, field slope ni biasa kalau dia melibatkan embankment, and then bila kita buat embankment or any excavation dekat kawasan pit area ataupun small area, kita akan pakai retaining structure. So retaining structure ni, kalau you go in any development area, memang kita tak boleh avoid retaining structure. Ada yang pakai anchor retaining wall, ada yang pakai flexible retaining wall, so ada yang pakai gabion wall, ada yang pakai gravity wall. Setiap wall ni memberikan fungsi yang berlainan. Ada setengah retaining wall tu memang dia bersifat estetik. Contohnya gabion wall. Dia punya objektif dua lah, selain daripada estetik, dia juga menampung tanah daripada mengalami kegagalan dengan berat dia sendiri. Ada setengah case application kita tu gabion wall tak cukup. Dia kena pakai sheet pile wall, dia kena pakai ball pile wall. So benda-benda tu yang you have to look at closely. Somehow bila kita buat reclamation area in ocean lah, contohnya kan offshore, so kita kena pilih the best retaining wall yang kita nak pakai. Kita nak against from kesan karat air masin tu kan. Kita nak buat construction dengan keadaan air tak boleh masuk dekat kawasan pembinaan kita. Bila kita buat construction in the middle of the ocean for example kan, ataupun kawasan-kawasan reclamation area dekat kawasan pantai, contoh Penang, Malaysia. So banyak kawasan yang memang telah ditambak. So bila ditambak tu kita nak kena fikirlah kaedah. Kita nak buat housing area, and then what will be the best retaining wall that can be used in the ocean area, so that when you do the construction, piling ke apa-apa, air tak masuk sepanjang tempoh pembinaan. So yang tu yang kita kena lihat, kesan selain daripada kita nak avoid air masuk, kita nak avoid kesan karat, kita nak avoid any failure lah. So the thing is that bila you dealing with geotechnical engineering, we try to avoid any failure and deformations. Deformations and failure bergantung kepada parameter of the material itself ataupun parameter of the soil. So selalunya bila kita plot graph lah ataupun when you do experimental work, you are looking two main parameters of the soil secara index testing ataupun mechanical testing. Mechanical testing ni adalah bila keadaan you nak tahu dia punya stiffness, you want to know the shear modulus, you want to know the young modulus, so you are conducting the axial load test for example. Kalau kata you nak tahu further on the strength of the soil, you boleh buat triaxial test, you boleh buat shear board test, kemudian you boleh buat unconfined compression test. So these are the tests yang memberi input, good input for you as a preliminary input before you starting doing the design. So design tu they can be done using hand design ataupun design by using the additional ataupun computational tool. So sekarang ni saya rasa kita memang tak boleh elak lah daripada IR 4.0. So when you do the design, try validate dengan hand calculation dan juga computer software. Okay, other than that, bila kita tengok embankment ni saya dah sentuh, yang ni saya kata geo-environmental engineering. We want to look at the environmental impact landfill. This is most closely bila kita ada open landfill lah. Open landfill ni dia tengok air ni nanti akan diguna semula untuk drinking water for example. And nowadays bila kita tak ada kawasan terbuka untuk any constructions, we have to do tunnel. Tunnel ni adalah satu medium yang mana kalau dekat Malaysia lah kan kita ada smart tunnel. Tunnel ni dia berfungsi dua. Satu laluan trafik di bahagian atas, kemudian laluan bawah tu adalah untuk water floodway lah. Tapi kalau kata di KL berlaku banjir besar yang amat teruk, smart tunnel ni dia akan tutup laluan atas tu untuk kereta. So totally dua tu adalah untuk laluan air saja untuk mengelak berlakunya banjir besar di Kuala Lumpur. So alternatively memang sekarang kita dah banyak guna tunnel lah untuk kita punya transportations ataupun water flow out, try to avoid any flood in hectic area, in compact area. Okay, the last, it's not last lah, but I try to just cover on part of the consolidation, preloading. Ini melibatkan embankment lah. If you want to construct road construction, kita nak buat jalan baru kan, kita nak kena ada, ya, sorry.
No,
Okay.
maybe it's from the participant.
Okay, okay. So bila kita deal dengan soft soil, contohnya in Johor Bahru ataupun in Penang itself, some construction cannot be done immediately. We have to treat soil. The treatment can be in any ways, in any methods, techniques. For example, ground improvement. Ground improvement antaranya adalah consolidations. The purpose we are doing consolidation is to speed up the process of the settlement. To speed up the process of consolidation soil, and then we allow to water dissipate from the soil particles. So itu tujuan kita buat consolidations. Berbanding dengan compaction ataupun densifications, is the purpose to reduce the air void contents between the soil particles. So bila kita tengok soil consolidation ni, bila kawasan yang banyak air ni, cara lain kita nak buang air tu, kita kena buat consolidation process. Consolidation process ni dia banyak additional dia. Contohnya kita letak surcharge, kita letak preloading, kita letak PVD, prefabricated vertical drain. PVD ni adalah satu dia macam satu medium lah untuk membenarkan aliran air keluar daripada ground soft. Okay, yang ni another teknik sekarang yang kita selalu tengok, ground treatment menggunakan stone column. Student saya pun dah study on the stone column. Kita nak tengok dia punya behavior, look at to the vertical displacement, what are the best stone column spacing kan, and then how many numbers of stone column can be applied on the site itself. Okay, the part on the role of geotechnical engineer, as you can see here, there are 4 important roles. For the first one is analyze and design. As I said, as a geotechnical engineer, we are not dealing only the constructions. Okay, I think that I need to stop for a while. Okay, sorry again. Okay, back to our discussion just now. As a geotechnical engineer, you need to know how to analyze and how to design. The thing is that, let's say you are choosing one design from foundations. You are having a problem site, and then you want to decide whether using deep foundations or using the shallow foundations. So as an engineer, first of all, you need to know the soil properties, and then you need to use the soil properties in the design stage. Do the analysis. Look at between the shallow foundations and deep foundation, which design that can give you best solution and suit to your problem site area. Somehow, when we look at closely from the all aspects, sustainable, economical, and then our durations project, we couldn't go to any of the options due to these reasons lah. As I said lah, kalau kita ada constraint budget, kita nak buat deep piling ni, tapi bila tengok balik cost satu pile, contoh kalau kita pilih steel pile, and kalau kita pilih pile yang murah, mungkin dia boleh jimatkan cost project. Tapi bila dia melibatkan problematic area, high water content, memang nak tak nak you kena pakai pile. So dalam you nak design pile tu pula, you kena tahu pile yang bentuk macam mana. Is it round pile ke, ataupun dia adalah square pile. In terms of the size itself, in terms of the length, that's the role of geotechnical engineer yang you kena tengok lebih. Kalau kata pile bulat ni, dia punya factor of safety berapa? Dia punya ultimate bearing capacity yang dia boleh cover berapa? Kalau kata pile 4 segi ni, macam mana pula? So you couldn't simply say, oh, I want to use this pile. No, you kena tengok as a geotechnical engineer, you kena tahu design dia, you kena buat analysis. Dalam design ni kita banyak teori, kita banyak formula untuk kita pakai. You kena look at closely before you make wrong decisions or make wrong solution and answer. Okay, dalam banyak-banyak application lah, tak kisah foundation ke, excavation, earth dam, embankments, so we tak boleh avoid. Tapi currently we are lucky because analysis dan design boleh menggunakan komputer. Contoh kita boleh guna Platsys, kita boleh guna Slope W, any other open source software untuk membantu kita buat analisis dan juga design. Other than that, geotechnical engineer also play in the construction supervisions and monitoring. Selalunya bila kita dekat site, kita tak boleh biarkan for example, if you are doing consolidations, we want to estimate, to predict the vertical settlement. We have to monitor, look at the performance of the soil, dia punya behavior. Hari pertama, berapa dia settle? Hari kedua, berapa dia settle? So the vertical displacement will tell you the soil properties and also the soil behavior. Daripada situ dia indicate adakah the consolidation has fully completed 100% atau dia baru reach to 50% of degree consolidations. So these are the things that as a geotechnical engineer, some you may work at office, ada yang bekerja dekat site. So you kena pergi dua-dua. Dekat office pun you buat analysis dan design, dekat site pun you kena pergi untuk buat supervision dan juga monitoring. The thing is that to ensure that the structure behave in a good manner ataupun in a safe manner. Kalau kata kita dah buat preliminary investigation, preliminary desk study, kita dah estimate dah, kita dah predict settlement supposed to be this number of displacement. Tapi tiba-tiba bila pergi ke site, lain pula berlaku. So you have to figure out why this thing happen. What are factors, causes? Adakah proses consolidation tu incomplete ataupun the number of PVD is not enough. So those are the things that yang you pada peringkat awal kita design mungkin lain. Bila dekat site tu dah jadi lain. So macam mana kita nak counter back, nak tackle balik isu yang berlaku dekat site. So yang ni lah bagusnya kalau you ada pengetahuan analysis design, kemudian you tahu juga nak buat supervision dan juga monitoring, and then how are you dealing dengan something unpredictable on site. Dan satu benda yang kita boleh tengok lah kan. The next one is the geotechnical investigation and troubleshooting. Ini selalunya kita try avoid any collapse or failure to occur. So deformations yang heavy ni kita try to avoid lah. This is the important geotechnical investigations. Geotechnical investigation ni selalunya is the preliminary pada kerja initial work. For example, kita akan buat standard penetration test. Standard penetration test tu kat situ you akan ada undisturbed sample, you akan ada disturbed sample. These are the preliminary input parameter of the soil yang menceritakan soil tu kategori apa. Adakah dia fine soil ataupun dia adalah coarse soil. Kalau fine soil, dekat layer mana, kedalaman mana dia adalah silty clay ataupun silty soil, in which depth dia represent as a clay. What are the important of the geotechnical investigation ni adalah untuk fasa, analisis dan juga design. So kita boleh buat design menggunakan input daripada geotechnical investigation. When we have the NSPT number, kita dah tahu dah nilai strength of the soil tu berapa untuk undisturbed dan juga disturbed. So yang ni lah bagusnya kalau kita boleh buat geotechnical investigation. Somehow bila kita ada limited budget, kita tak buat pun geotechnical investigation. Kita boleh kita ambil desk study from other history record, tapi yang ni kena buatlah public connections, dapatkan daripada public authority lah untuk dapatkan maklumat tersebut. Atau you can do simplest or cheapest geotechnical investigation, contohnya JKR probe test. So JKR probe test or Macintosh probe test pun adalah benda yang boleh cerita pada awak, that tells you the bearing capacity of the soil. The important part about the soil adalah kita nak tahu dia punya strength dia, kekuatan tanah tersebut. How much the maximum load can be applied ke atas struktur supaya bila you design factor of safety dia, they can give you around 2 to 3 for example. Ataupun you design slope, dia boleh bagi FOS around 1. So yang itulah benda-benda yang kita kena lihat pada peringkat permulaan. So soil testing and site investigation ni is important to obtain parameters for design, monitoring and also investigations. Okay, these are the applications in geotechnical engineering. For example, you are dealing with a deep foundation, somehow it's a mat foundation, raw foundations, and then this is cannot be avoided having the deep excavation and underground. So look at the retaining wall itself. So they're not using the simplest retaining wall. So you have to design the size of the retaining wall, dia punya lebar dia berapa, kedalaman dia berapa kan, supaya bila you buat construction dekat underground ni, kita boleh elakkan any failure ataupun sebarang benda-benda injury lah daripada berlaku. Okay, this is another one on the ground improvement. So ground improvement ni dia ada beberapa teknik terlibat lah dalam ground improvement, bergantung kepada soil profile. Kalau kata in Malaysia lah, commonly dia melibatkan 3 teknik lah. Contoh kita ada consolidations, bersama dengan consolidation kita ada reinforcement, and lastly we have a compactions. Tapi as I said lah, in order to choose whether you use all these 3 methods, dia bergantung kepada soil profile kita. Soil profile ni sama ada fine soil ataupun coarse soil. Just mention the major group sahajalah. Tapi kalau tengok betul-betul soil profile ni, dia banyaklah bergantung kepada British standard. Dia in order to categorize sama ada coarse ataupun fine soil tu pun ada dalam standard British. Macam mana kita nak classify dari segi kandungan. Kalau kata coarse soil is more than 50%, dia sepatutnya apa type of soil, classification dia macam mana. Kalau kata dia less than 50 ataupun 35, they can go to the second group of the soil, iaitu fine soil. Okay, ini adalah salah satu 3 applications lah. On top is a slope stability, and at the bottom is a soil improvement, force upgrade, and the next on right side is a soil reinforcement. And when you look at to the soil reinforcement, as I said, it can be done together with improvement. Maknanya sebelum kita nak letak soil reinforcement menggunakan geomembrane ataupun any geomaterial, kita akan buat improvement lah, bergantung kepada initial soil properties dekat kawasan tersebut. Kalau kata kawasan tu memang very problematic soil lah, so you have to treat dulu, improve dulu dia punya soil behavior, soil properties dengan any admixture, sama ada natural admixture ataupun you menggunakan lime powder atau you menggunakan any natural waste such as sugarcane fiber. So benda-benda tu you boleh improve terlebih dahulu, barulah you letakkan geomembrane. Geomembrane ni kalau you look at closely lah, there are many companies involved in the selling geotechnical product. For example, in Malaysia, we have many. One of it, I don't remember the company names, but they are specialized in producing geomembranes. What they are studying or what they are researching on the size of the geomembrane itself. Are they using the hexagon, or they are proving or they are producing geomembrane in circular shape? All this shape of the membrane giving you different strength. For example, if you're having a hexagonal shape of the geomembrane, that will tell you different strength of the geomembrane itself. And then hoping that when you place on the soil surface, that will be strengthened or reinforce the soil for the applications. So itulah tujuan kenapa bila you tengok geomembrane ni ada yang bentuk hexagon, ada yang bentuk bulat, ada yang bentuk 4 segi. So semua produk-produk yang dihasilkan untuk geotechnical application ni melalui CD kajian lah. So kita nak tengok kan in terms of the material tu, dia punya size dia punya bentuk dia, diameter dia, ataupun dia punya B darab D or B darab H itu berapa. So yang tu melibatkan aspek analisis dan juga design lah. Okay, the next one on the part of applications between soil improvement dan juga reinforcement, I try to make difference from the meaning itself. Contohnya, soil improvement is an alternative considered when the natural soil does not meet the engineering requirements for a project. Ini yang kita kena buat improvement. Bila kita tengok dia punya engineering properties ni very weak, so dia tak boleh langsung nak construct apa. You pijak sikit pun dia dah settle, dia dah termendap kan, tanah tu mendap. You pergi site, you baru jalan sikit je, kasut you dah kotor. Maknanya tanah tu memang content high water. So macam mana kita nak buat? So kita kena buat banyak kaedah lah, ataupun yang dia cadangkan di sini antaranya without admixture in coarse green soil, without admixture in fine-grained soil, with replacement, grouting, and admixture or with inclusion. So kita boleh tengoklah antara 1 hingga 5 ni mana kaedah ground improvement yang sesuai dengan our soil at the site project. And then apa faktor-faktor yang mempengaruhi kepada soil improvement ni? For example, here soil type. As I said lah, kalau you look at 2 major soil type, sama ada fine ataupun coarse grain, you kena tengok what are the best thing. Tak semestinya you ada fine, you ada clay soil. Kemudian you nak pakai kaedah densifications, compactions. So this is not right. Am I said kan kenapa kita kena buat densification, kenapa kita kena buat consolidations. So bila kita ada high water content, of course the best way to improve the soil bearing capacity ataupun the soil strength, having the consolidations dulu. So kita kenakan consolidation, kita letak PVD. Maknanya kenapa kita pilih consolidation? Kenapa kita tak buat compaction ataupun densification? Because kita dah tahu dah tanah tu memang high water content. So that's why in order to choose the right method for ground for improvement ataupun soil reinforcement, you have to look at the properties of the soil. Tengok tu dulu, dia punya physical properties dan juga dia punya geotechnic, dia punya mechanical properties. Physical properties ni, for example, soil classification lah, berapa percentage fine, berapa percentage sand, berapa percentage gravel, berapa percentage silt, berapa percentage clay. So benda-benda tu lah yang akan direct you the right method untuk buat improvement, for example. And then fine content and size, soil strength and compressibility, area depth and treatment. Okay, just now I had a conversation with Miss Fitria. She said that she had experience on pit soil, which she did on research compressibility. And so dealing with the problematic soil will bring you to different of view, yang mana you akan tengok, okay, soil ni yang kita pijak ni sebenarnya banyak jenis. Dia bukanlah satu jenis saja. Dia bukan kata fine, dia bukan kata coarse. Kadang tu dia ada mixture antara fine juga, dan juga coarse. Dan kita nak tahu percentage dia berapa kan, kenalah buat soil testing. Contohnya particle size distribution test. And then when we talk about dia punya strength, nilai C dia berapa, cohesion, and then the internal friction angle, the apparent angle, angle masa dia peak strength, masa dia residual strength, berapa dia punya value tu. Value tu dia akan memberi impact kepada application design you. Contohnya kalau you dealing with the slope kan, slope ni kita nak tengok dia punya stability in term of the short stability ataupun long term stability. So bila kata short term stability, selalunya soil in the undrained conditions. Kemudian bila you cerita pasal long term stability, selalunya in the drain parameters, drain strength. And during that time, sometimes when you want to do the cut fill untuk long term stability, kita kena guna dia punya residual strength. So this time maybe you need to have some laboratory data kan, ataupun you dapatkan data-data dari past literature, tengok dia punya results berapa sebelum kita boleh buat analisis dan juga design. I have attended one webinar lah, satu tu dia cakap the most important bila you dealing with the geotechnical, sama ada you buat eksperimen ke ataupun yang lagi penting tu modeling lah, is the important part is input parameters. Input parameters apa yang you masukkan dalam modeling tu, dia akan memberi you result dia, sama ada good ataupun bad. Whatever input yang you masukkan, they tell you result. You as a geotechnical engineer has decide sama ada result yang you dapat tu memberi kepada good solutions ataupun bad solutions. You need to understand how to interpret the results lah. What I mean is that because it's like a garbage in, garbage out. You masuk berapa, dia keluar je nilai. Because this cannot be think out lah, macam kita as a human kan, kita boleh fikir, oh kalau kita masuk nilai ni, variations of the value strength, kita boleh tengok dia punya failure ataupun deformation, bearing capacity dia berapa. So kat situ kita dah boleh buat justification, judgement, apa kaedah yang sesuai untuk kita buat untuk project sustainable, for example. What are the best option design yang kita boleh opt to have a long term stability. Okay, and then the next one is reinforcement lah. It's a method used to stiffness and strength of soil geogrid. Okay, method of reinforcement is in situ reinforcement, nailing. Nailing ni selalu nampak lah dekat kawasan cut slope. Nailing anchoring, dia bergantung juga tahu kita nak pilih nailing atau anchoring ni, you kena tengok you deal dengan rock ataupun you deal dengan soil. Kalau kata you deal dengan rock yang banyak weakness plane, so maybe anchoring is good thing, because bila you anchor kan, you dah kenakan weakness plane antara blok-blok tu, so you dah grip dia, you dah ikat dia kuat dalam satu reinforcement steel bar contohnya. In order to ensure that the failure could not be occur in future lah. So bila you buat kan, kadang tu kita tak nampak pun dia dah mengalami proses nailing anchoring. The only thing bila you ada structure yang terjulur daripada surface. Ataupun kalau you tengok kita ada shotcreting. Shotcreting pun salah satu kaedah untuk prevention any water infiltration into the slope surface. So faktor dia sama. That's why I said bila you pergi improvement ke reinforcement, you're going to see that oh, the same thing, factors dia, kemudian the method approach to solve is the same thing lah. Okay, and then the next one is part of the Teknik. Teknik ni kita ada drainage method, we have vibration methods, grounding injection, chemical stabilization, soil reinforcement, and then ground improvement kita ada heating, preloading soil, vacuum consolidation, ground freezing technique, soil nailing technique, and etc. Okay, untuk chemical stabilization, due to our concern right now to avoid or to prevent any air pollutions or any environmental effect, you can see that the research trending is using natural waste as a stabilization admixture ataupun stabilization material. So now we try to avoid using lime, for example, because when you look at closely, lime can produce high carbon dioxide emissions. So that is not good to our environment. Okay, please, moderator, could you please play the short video here for ground improvement?
Okay, yes.
Okay,
maybe
thank you.
the committee will help Lewin. Can you help to play the video? Maybe you can stop sharing. Stop first, ma'am. Miss Masyitah, maybe you can stop sharing. Mungkin Lewin langsung di play saja, nanti mungkin bisa langsung gitu. Okay, the video has stopped. Maybe Miss. Okay. Hello? Hello, Miss Masyitah. Can you hear me? Oh, okay. Okay, can
Okay,
you tell
sorry.
me? Yes.
Okay, have you played the video?
Yes,
Okay, thank you, because
already.
I lost connections. I hope every one of you enjoy. So I will share some screens from mine. Okay.
Yes, you can continue your
I might
presentation. Yes.
Okay. What do you understand from the video? Because just now I'm talking about the what we call here. Okay, you can join using the class code right now. Okay. And then can you tell me what do you understand from this video?
I haven't shared your screen
Oh,
yet.
oh, okay. I think that oh, sorry. I missed that one.
Yes.
Okay. Right. Okay. What do you understand from the video? Okay, it's about ground improvement. But as I said earlier, in Malaysia, somehow we can have free methods just to do the ground improvement. It can be consolidation, it can be reinforcement, it also can be densification or compactions. What do you think about this one? You may, from the video lah, what's your answer? You using the same code 73499 or you can scan QR code again. So we have around 21 participants. Okay, I think that maybe the video very fast and very short in explanations, but I try to explain is that in this video is only involve densifications, because when you look at just now, it has a very big size of the particles. I mean that in terms of the in the soil group, soil classification is a coarse grains. So when we are dealing with the coarse grain, which high void contents, so we need to do the densification or compaction to reduce the air void contents of the particles. Sorry. Okay, the next one will be, hold on a second. Okay, the next one will be on this part, the applications. So as I said again, when you go to improvement application or reinforcement, it can be in the branches of geotechnical engineering. For example, road construction, cut slope, retaining structures, foundations, temporary structure, and excavations. The same thing is that for reinforcement techniques, in the earlier slide, kita ada few methods such as some surface compaction, drainage method, vibration method, compression and consolidation, grouting and injection, chemical stabilization, soil reinforcement, geotextile, and geomembranes. Okay, again, the same thing applications from just now, improvement, cumanya ada setengah keadaan soil profile tu kita kena gunakan dua kaedah. Improvement pun ya, reinforcement pun ya. Contohnya kalau melibatkan very high water content or problematic soil. Okay, other than that, deep excavation and underground.
I'm sorry,
Any
Mr.
common practice lah in Malaysia.
Mrs. Masyitah, you have
okay.
50 minutes left.
Okay, never
Yes.
mind. I'll try to make on the part last when we go to the next thing about our talking just now lah, industry and sustainability. Okay, the thing is that when you come out with the case study in Malaysia, they try to produce some applications project yang memang reduce in carbon dioxide, and also in comparison when you go to the between SDG 9 and SDG 11, dia adalah interrelated. Dia sama dengan macam yang saya explain tadi, kita melihat kepada tiga aspek dari segi environment, economical dan juga social impacts. So the main the main things on the talks here is on the infrastructure project. As I said, it is involved dengan design, operation, construction dan juga practice. The purpose kita buat sustainable ni from the sustainable infrastructure ataupun green infrastructure ni adalah kita nak try to minimize all the impacts from social, environment dan juga economic. Contohnya kan kalau green infrastructure tu we can use waste material and then kita kena fikir on part of the less hazardous, less volatile organic compounds. But the most important when you are dealing with these kinds of the projects, we have to look at to the factors. Apa faktor-faktor yang kita perlu lihat untuk pastikan construction kita tu sustainable? For example, alignment, material and resource, stormwater management, and then go to the energy, environment control, construction activities. Lastly is the innovation design. So the next slide, you can see that how all these cases that I show you, macam mana they make decisions in order to sustain from any environmental ataupun from social or economic aspect impact. Dia melihat kepada teknik dan juga options. Ada satu case yang mana saya tunjukkan di sini macam mana dia berurusan dengan landfill area yang very problematic high water content. You look at to this one daripada soil type tu kita dah nampak dia punya color tu color grey and high water content. And then you go to the soil properties, you dah nampak dah silty clay around 86% and sand only 14%. So which the best method techniques yang saya bagi tahu awal-awal tadi kan sesuai untuk improvement. So in this part sebelum dia nak pilih teknik mana yang sesuai, they go to the design and options dia. Dalam kes ni dia ada three options. The first one option yang mana dia akan construct dengan stabilize 300 mm untuk achieve CBR 30, ataupun option kedua dia buat remove and replace 300 mm, ataupun option ketiga dia remove and replace 1 mm CBR as material. So in order to choose the best method for improvement or reinforcement, you look at to design aspect, operations dan juga construction. In this case, first case ni saya menunjukkan macam mana daripada design aspect ni dia buat satu keputusan untuk sustainkan dia punya project tu. So ideally bila dia plot, bila dia keluarkan dia punya data, they can see that the depth of excavation from the top of subgrade kosong untuk option 1. Maknanya kalau pergi option 2, option 3 yang konvensional tu kan, yang kita ambil imported fill soil and then kita dump dekat site tu, baru kita nak buat dia punya improvement teknik. So kat situ dia dah melibatkan additional cost, extra cost. So bila kita cerita pula comparison in terms of the money, you boleh nampak the option 1, option 2 dan juga option 3 in terms of the ringgit Malaysia per square meter ni kan, dia nampak option 1 lebih menjimatkan. So this is the best stabilization method untuk antara 3 option, yang ni yang terbaik. Maknanya dia buat stabilization dekat site kat situ. Dekat situlah dia letak lime powder, kat situlah dia improve the soil properties. Dia tak payah ambil borrowing material daripada kawasan lain, dia tambak dekat kawasan landfill area yang saya tunjuk tadi. So kat situ kita dah nampak lah macam mana the initial part of the design, kemudian you buat some sort of study sikit, you buat analysis, you buat data comparison, you akan dapat the best result for the methods untuk you guna. Sebab kita nak make it our project sustainable. Okay, the second part is on the second case lah untuk saya tunjuk adalah ground improvement. So ground improvement macam saya explain just now lah, they can be applied on road construction, high-rise building, etc. But this time saya nak tunjuk macam mana ground improvement untuk satu kawasan warehouse area. Warehouse area ni pun as I explain lah, yang ni pun you dah dengar tadi ground improvement teknik. So daripada beberapa options, beberapa solutions yang dia dah propose, contoh kat sini dia ada 2 option. The first one menggunakan deep foundation dengan 25 cm thick RC slab on piles, ataupun dia menggunakan shallow foundation, loose fill improved by dynamic compaction with 15 cm thick RC slab and 30 cm thick compacted granular layer acting as a load transfer layer. Okay, macam mana they decide that the best one antara solution 1 ataupun solution 2? Remember, we want to sustain our project. So apa yang they can come out is that dia tunjuk comparison tadi antara solution 1 iaitu deep foundation, solution 2 dengan shallow foundation. Dia memberikan satu keadaan yang mana option number 2 in terms of the carbon dioxide emissions CO2 ni lebih lebih kurang kesan dia berbanding dia pakai deep foundation. Sebab apa? Bila dia pakai deep foundations untuk karakteristik yang dia dah set lah untuk dia punya design sama ada deep foundation ataupun shallow foundation, dia nampak piling ni consume more energy, 0.49 kg, and then concrete 4 pi is a 15 kg per week, and additional concrete. So semua ni is not good in terms of the material in order to sustain the impact ataupun kita nak kurangkan kesan-kesan lain. So in order to choose which one is more sustainable, so the best option, the best solution is the shallow foundations. So sebab bila dia buat pembandingan, dia punya CO2 lebih rendah berbanding bila dia pakai deep foundation solution. So yang ni pun you can see lah from here. So solution 2, shallow foundation is more suitable for warehouse project. And the next one for soil improvement is a reinforcement. Reinforcement kat sini saya nak tunjukkan reinforcement can be applied on retaining wall dan juga slope protections. Tapi dalam case ni salah satu projek dia yang ada di Malaysia adalah Duta Ulu Kelang ataupun kita panggil Duke Expressway. Okay, Duke Expressway ni is something that kita kena fikir in terms of the material yang mana dia lebih menjimatkan energi. Okay. The purpose we are doing the expressway because we want to short our distance, save time and etc. So bila kita dah jimatkan masa perjalanan, kita dah jimatkan minyak, indirect meaning that kita dah mengurangkan penggunaan minyak kereta. Kemudian kita dah mengurangkan kesan carbon dioxide. Remember, bila kereta yang bukan electric car ni, kesan-kesan pencemaran udara tu tinggi kan. So bila kita ada expressway ni, kita dah nampak of course this will be beneficial. So bila dia buat expressway ni, kita kena pilih lah the best material yang mana boleh menjimatkan in terms of the cost dan juga menjimatkan masa dan menjimatkan semua aspek. Okay, challenges. Challenges in this part, I try to summary all aspects in the constructions. For example, money, material, labor dan juga method of constructions. So method of construction ni you kena tengok dari segi design dia, you kena tengok dari segi operations dia, you kena tengok dari segi constructions activities dia. Okay, all these aspect bila kita nak tengok kita mungkin win 3 out of 4 factors. Tapi kalau boleh kita nak try tackle dia punya cabaran tu ke semua. Dari segi money pun kita optimum, material pun kita boleh jimatkan, kemudian labor cost pun kita dah reduce, method of construction of course. If you look at closely current trend in construction and material, contohnya sekarang orang dah banyak guna IBF, Industrial Building System. Kemudian dalam labor cost pun kita dah reduce, kita dah banyak pakai IoT, kita dah pakai BIM, Building Information Model. Kemudian with the helpful of cloud database, cloud management, kita dah ada web base. So labor cost ni dah boleh berkurangan. Maknanya in terms of the aspect of the project lah kan, bila kita melihat keseluruhan cabaran-cabaran ni kita boleh improve kan bila all aspect, all the parties, all the relevant authority think together macam mana kita boleh menghasilkan satu activity construction project that fulfill the SDG goals. Itu yang benda yang everyone has to think out how to do construction at the same time dia memberi you sustainable impact. Sustainable impact ni kalau boleh kita look at from the three things, economy, environment dan juga social. So when you go all these things, method of construction, labor, material, money, dia akan jadi satu benda yang kita buat pun kita happy lah kan. Dia not be orang kata apa, regretful lah. Okay, the last I can say is that the way to get started is to quit talking and begin doing. So let's make our world sustainable in achieving SDG goals. So I only talk a few SDG out of 17. So I hope that this can be very orang kata apa, beneficial webinar untuk every participants to take concern, to take serious on this matter. Okay, in summary, with the proper planning and monitoring in design, operation and constructions of project, the sustainable infrastructure and green infrastructure geotechnical projects are beneficial in producing renewable and efficiency energies. So that's end my presentations this morning. thank you for having me, and sorry for you have taken a long time ataupun ada lost connections or a few minutes break just now. Okay, I pass over to moderator.
Okay, thank you very much, Mrs. Masyitah. Don't worry, we have some problem about this about the signal.
Oh yeah, suddenly lost.
Yes.
I'm not sure why.
Okay. Thank you for giving your valuable insight about the sustainable of geotechnical infrastructure engineering and some cases that happen in Malaysia, right? Yes. Okay. So with that, we will go ahead and maybe take some question from the audience, maybe. Okay, please, the participant, if you want to ask about the sustainable or everything about geotechnical engineering, maybe the how to overcome your problem project in some time. Maybe Mrs. Masyitah can give her best experience about the geotechnical engineering, especially and sustainable of geotechnical infrastructure engineering. You can ask in English or in bahasa Indonesia, boleh? Boleh. Or you can use your feature raise hand, maybe. Okay, we have one question from Mr. Muhammad Muntaha. He's my head of
supervisor.
Yes, head of the Laboratory of Geotechnical and Transportation in Civil Infrastructure Department. Okay, please, Mr. Muhammad Muntaha.
Thank you for moderator, Ms. Fitria. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Nice to meet you at a webinar at Civil Infrastructure Engineering at ITS. It's nice to see you. Maybe someday we can collaborate together at research in Indonesia or at Malaysia. I have one question. Maybe you have some experience for research soil improvement. Masyitah, maybe you can you ever research with fly ash or cement or maybe you can tell to us how your experience about the research. Maybe that's my question. Thank you. Assalamualaikum.
Salam. Thank you, Mr. Muhammad Muntaha. Okay, as I said earlier, when we are choosing the right research topic, and we are concerning about the waste, natural waste. For this time, my research using the cockle shell waste. So as you know that cockle shell waste is a natural waste. Why when some people will hear that why cockle shell waste? Why not you are using fly ash or lime or etc. Because the first one we want to use the green material, material that can improve or can help the reductions of the carbon dioxide emissions. One thing is that on part. But the thing is that when we are dealing with the cockle shell powder, it is a powder. And then the fine itself to be bind together in the soil mixture is getting our concern to know further the characteristic as well as the strength of the material. Because of what? When I and my student did on the few research experimental work, we did on the soaking and unsoaked purposely for road construction application subgrade. So we know that in Malaysia, heavy rainfall, and then of course the subgrade will be fully filtered with the water, and we want to see the impact of the water infiltrate to the subgrade. So we did experiment on the soaking sample and unsoaked sample. So it shows that the fine powder itself could not help to improve the soak numbers or the soak value. So I am thinking to investigate the details, the properties of the cocktail itself before turned into the powder. Maybe the cocktail cannot be used as a powder. It can be used as a reinforcement, such as in the particles of kepingan-kepingan lah kan. So kalau kita gunakan powder tu, dia tak sesuai berbanding kita gunakan kulit kerang yang betul-betul terhasil tu. Dan my concern is to look at the effect of organic matter. From the organic matter, this influence the properties of the soil treated with the Caucasian. So bila kita tengok benda ni kan, kita lihat, okay, are we going to proceed or continue our research in the same area, or we have to improve with the additional admixture to bind together, become as a primary and secondary admixture, just to improve what we have result from last time, or we just leave it. As a researcher, we are eager to know what's behind this. Is this enough using the find itself, or we need to use additional supporting admixture material so it can bind stronger together in the soil admixture? That's I mean, I'm not choosing the fly ash, I'm not choosing the lime, etc., because the purpose is that we try to reduce the natural waste. So in Penang, because we are close to the coastal area, so the Caucasia is easy to obtain. So I encourage my students go to green infrastructure material, because that's how we can see is the soil improve before adding the Caucasia, or it just at the certain or at the certain characteristic after we adding the Caucasia. So that's another thing that I am thinking to explore more, to figure out more why this thing happen, because we are having some guidelines our results finding. Kita nak tengok kita punya finding ni meet to the requirement public authority or not. So we did on the comparison, etc. So bila kata some result is not supporting, we have to think out what are the best thing. Adakah dengan satu admixture Caucasia tu tak memberi significant impact? Maybe Caucasia powder need to add dengan lime, for example, to bind together, so that it getting stronger. So bila dia dah bind, mungkin dia akan lebih elok. Itulah yang saya cuba hasilkan, cuba untuk lebih mengkaji benda yang bersifat green material lah. That's my own personal experience and opinion on the previous question by Mr. Munta. I hope that I answer your question.
Yes, that's the answer from Mrs. Masyitah. What about that, Mr. Muntaha? You want to ask more, or
maybe Mr. Muntaha also can share his experience, because we have a different interest. Some people will like use fly ash. Some people may think that why not we use the waste material, because the trending is there. For example, I'm not sure about Indonesia's research trend, but I think that people talking about how we can sustainable our project, our research, because sustainability ni boleh tengok dari segi produk tu sama ada dia adalah struktur ataupun dia adalah dalam bentuk material. Maknanya kita tengok kat sini hard infrastructure or soft infrastructure kan. Kalau soft infrastructure ni mungkin dia lebih kepada material asal dia tu. Atau kita boleh lihat dari segi aspek design kan. Design mixture tu pun dia melibatkan design juga. Nak campur ni, berapa ratio dia. Caucasia maybe 5% is not enough. Maybe we need to add more 10%. But from my reading, 5 to 10% is the optimum number of the admixture content, if I'm not mistaken. From my reading and research.
Yes.
Okay, thank you, Encik Masyitah. That's right.
Welcome.
To call you Encik Masyitah.
Madam, my student call me Madam.
Madam Masyitah.
Okay.
I think you have a good opinion and very much experience.
Yeah.
So maybe someday we can get some collaborations
Of course.
to make joint research, maybe something like that. Because in Indonesia we have many problem corresponding with soil. We have many subsoil. We have many I think I forget earthquakes and the other problem.
There's a lot interesting to study.
Yeah.
Doing research also.
Interesting to we can collaboration research.
Inshallah.
I think enough for me, Miss Fitria.
Yes,
maybe the other participants have any question. Thank you.
Okay, thank
Madam
you,
Masyitah. You.
Mr. Muntaha. Thank you, Pak Muntaha. Okay, maybe for the second question, please raise hand, or you can write your question in chat box in bahasa or in English. Okay, maybe while we're waiting about the other participant wants to ask, maybe I just want to ask you something, Mrs. Masyitah. What's your excitement about study in geotechnical engineering? Maybe your insight might have to encourage our students to learn more about the geotechnical engineering.
For me, geotechnical engineering is a mystery. That's I can say that, because from the underground to subsoil to the subgrade to the ground layer, ground surface, it's a very it's not a fixed answer that all problems can suit with. That's I mean. Maknanya satu masalah tu dia tak boleh pakai untuk kesemua kan. Maknanya bila kita pergi Indonesia contohnya kan, masalah dia lain. So solution yang dekat Malaysia mungkin tak sesuai, tapi mungkin juga sesuai. So dekat situ dia punya, I like to have that interest bila kita berfikir macam seolah-olah benda tu misteri lah kan. Kalau ikut pengalaman saya belajar kan, even saya tengok my students sendiri pun, kalau antara geoteknik dengan structure, mereka lagi suka structure. Mereka suka structure sebab structure adalah satu yang you analyse, you design, you buat calculation, you nampak. Number tu nampak. Betul tak? Geoteknik ni tak nampak. Berlaku settlement pun, berlaku settlement dekat underground pun, dekat ground surface pun, dia akan ternampak terhasil dekat bahagian permukaan struktur, dekat lantai. Tak pun sekali lagi dinding kita. Tiba-tiba tiang kita tu dah berpisah dengan dinding kan. Awak pun duk fikir pasal apa. You dah tahu dah ada ground movement dekat bawah tu. Tapi macam kita nak selesaikan problem tu, it's not as easy way lah kan. So that's why I said, kalau you berminat dengan struktur, you bekerja dalam struktur division as a structural engineer, dia akan ada some interrelations yang you memang kena tahu nak design pile cut contohnya. Macam mana you nak design pile foundations dari segi size dia. Sebab itu melibatkan structure kan, konkret dia. Kemudian daripada pile tu sebenarnya, dia adalah major structure yang cater the whole building punya berat. So bila you relate semua benda tu kan, you akan nampak something that it's a mystery lah. Macam saya cakap lah, you macam main game, you eager to go next level, next step kan. So you nak tahu lagi, you mencari. Bila you terus mencari, dia akan bawa you kepada satu arah, oh this is your interest. And then bila kata macam mana kita nak encourage student untuk minat dalam geotechnical engineering adalah, we need to spark their mind, their think on the certain problem or any certain project. Case lah kan, kita bagi dia satu contoh and then kita respond dia different way untuk cater lah, untuk tackle the issue lah. Contoh kalau year 1 student lain, year 2 student lain, final year student lain. Kalau final year student, kita mungkin lebih banyak bagi dia problem based, problem study case. Contoh kalau dulu my experience teaching in geology. Geology and geotechnical engineering lagi, I think that my opinion geology lagi lah. Nak tarik orang minat geology tu lagi lah kan. Dia tak semacam geoteknik tu. Geology dia main dengan batu lah. Batu je lah you tengok kan. At least kalau soil ni kita tengok batu, kita tengok soil. Kalau geology ni dia pergi kat batu. Tapi peluang untuk geology ni bestnya dekat kawasan ataupun dekat area offshore field. Offshore field kat situ kan dia nak cari minyak mentah. Minyak mentah tak dekat tanah. Dia ada dekat bahagian lower ground of apa kata ocean dekat bahagian dasar. Kat situlah peranan geology ya. Geologist. Kalau geologist ni dia punya knowledge in geology, bahasa batu, dekat mana rekahan ataupun dekat mana sumber minyak mentah. Itu orang kata apa, adalah group of kelompok. Macam kes geoteknik ni sebenarnya dia lebih jelas lah, dia lagi nampak berbanding geology. That's why I say that if you make comparison antara geology dengan geotechnical engineering, I think that geotechnical engineering lebih can be seen lah berbanding geology. If you nak sentuh dengan structural engineer, lagi glamour lah structural engineer berbanding geotechnical engineer, betul tak? But the responsibility for me lah, dia balik pada geotechnical engineer lah. Sebab kalau geotechnical engineer salah design foundation, deep kan, dia punya size deep foundation, salah dia punya diameter ke, lebar darab H ke, pile length tu salah, dia nak pass dekat structural engineer pun tak berani lah kan. Ataupun salah tu boleh datang daripada structural engineer. Structural engineer salah kira loading kan, daripada dead load, live load. Kemudian dia kira-kira setiap floor until to the last, and then dia nak transmit pula final loading tu kepada foundation. So on the initial superstructure loading calculation pun dah salah, dia akan effect kepada substructure. So bila substructure tu salah, so both dua-dua lah dua-dua lah bertanggungjawab kan.
Yes.
So I want to show that how important as geotechnical engineer lah. So minat tu kena ada lah kan. Betul, geotechnical dengan structure memang ramai minat structure lagi.
Yes.
Kan, I think that pergi mana sama jugalah kan, dia punya trend dia punya student punya interest tu kat mana kan.
Yes, and one of my lecture when I got my master said geotechnic is a dynamic problem because substructure is a static problem. Okay. For the comparison, geotechnic is always changing, right?
Good comparison lah. Because you and Indonesia lagi dekat seismic earthquake kan. Macam kami Malaysia kan baru ada yang impact yang last time kan, last 5-10 years ago, baru kita interrupt to the seismic design kan, baru kita ambil lateral load dia berapa bila nak masuk kat dalam pile design kan, pile foundation. But this thing as I said lah, dia restrict kepada kita punya standard lah, sama ada yang menggunakan British standard ataupun Eurocode standard. Practicingnya mana standard yang kita pergi kan, itulah.
Yes. Yes, it's a lot of interesting. Actually, if we're talking about geotechnical engineering.
Yes, it's true. It's very interesting actually kalau betul nak tengok kan.
Okay, we have a second question from our Civil Departemen, Mr. Muhammad Khairi. Okay. You can unmute, Mr. Muhammad Khairi. Yes.
Halo, Dr. Masyitah.
Hi.
I want to ask one question because my students asked anything. How about the using a geopolymer material for soil erosion in Malaysia? Because in Indonesia, a lot of research work on geopolymer material, but in concrete material, not for soil erosion. How about in Malaysia?
Okay. Thank you for the question. I think that a good question also. Polymer material. If you look at to the trend in Malaysia, we are also heading to that one. But something that you need to concern about the polymer itself lah, because the polymer ni kalau betul-betul dia tengok kan, dia tak sama macam. That's why I said lah, people like to do something that can be seen. Kan macam kita nak tengok kesan dia, bila letak ni nampak kesan dia kan. So polimer dia bukan tak nampak, cuma dia punya interest tu dia tak bawa lagi ke situ, dan dia bergantung juga di mana anda berada, di mana research tu anda buat. Macam contoh kawasan saya, I'm in northern peninsula of Malaysia, so my area memang very close to the coastal kan, so we are concerning about the natural waste material. Other than that is that bila you talking about the polymer ni, kita kena cari polymer yang easy to be found, kemudian dari segi material cost dia cheap. So kalau you nak buat betul-betul research work yang melibatkan polymer yang berbayar kan, so itu antara our challenges lah, constraint. So that's a good thing that I can approach in my future research, but need to think also about the cost effect lah. So for this moment, I'm sorry to say that for my area, the polymer inclusions as a soil stabilization still lagi dalam keadaan orang kata taklah banyak sangat dia punya orang kata interest, banyak lagi menggunakan geomembrane, geotextile, semua macam itulah. Kalau kata fiber pun dia banyak guna yang natural fiber. Itu.
Thank you very much, Dr. Masyitah.
Okay, welcome.
Okay, thank you. Maybe for one last question before we end this session of about this webinar. Okay, maybe it looks like we've covered of our question, Mr. Masyitah, and we come to the end of our discussion webinar in sustainable of geotechnical engineering infrastructure in Malaysia, especially that you've been shared. Maybe before we wrap up, is there anything else you wanted to share again about geotechnical or about the project or about everything?
Okay. First of all, thank you for inviting me. And then I just want to conclude is that sometimes what we are doing, we are not realizing actually we are involved in the sustainable environment. I mean that in terms of the infrastructure project, in terms of the materials, we are looking for green material is part of the sustainable. So sometimes when we look at closely, the world trend is doing research in sustainable can be seen on their papers research. As well as in Malaysia construction project, I have read and I have seen a few construction projects that involve in mega structure, for example. Whatever they are doing, they keep in mind that sustainability is a number one. I mean that the environment impact must be reduced, and in terms of the design, we need to choose the right design, the right solution, so that there is no other adverse or huge impact to all aspects as I explained. So so again, when you are doing whatever things in geotechnical engineering, especially, we have to do some sort of verifications, validations, and look at all the aspects from sustainable, IoT, innovations, dan juga creativity. The creativity for this, I mean that in order to give an option, solutions to whatever problems you may encounter on sites, for example. Contohnya, kalau kata kita nak buat satu solutions ni, kalau kata solution A tak boleh, solution B macam mana? Mungkin solution B is not good. You need to opt dengan solution C. How you are creative or innovative in tackle the issue. So that's, and from me lah, my short explanations and summary about the sustainability, and sorry for the lack exposure on the KISS project that concerns in sustainable in Malaysia. But as I said earlier, all the public authorities in Malaysia already taken seriously the sustainability element, SDG goals. So I can see from projects, from the guidelines and etc. So this is not about Malaysia's concern, it's all about worldwide concern in SDG. Thank you.
Thank you, Ms. Masyitah. Oh, maybe there is, before we're closing our webinar, Mr. Muhammad Muntaha has raised his hand. Maybe you want to ask again?
Sorry, last question before Dr. Masyitah close this webinar.
Okay.
I think you not tell to us about University Mara at Malaysia and your department, maybe about postgraduates and at your university. And the last one is how about scholarship, because in this webinar, many our students at this webinar, maybe they can get the challenge to get a scholarship at your university.
Okay.
Okay, thank you.
Welcome. Thank you for the questions. I think that there's a good things if we can have more collaborations, joint ventures program. So for your informations, UiTM UiTM is the biggest public university in Malaysia, which has around 13-14 campuses, and UiTM Pulau Pinang is located in the northern peninsula of Malaysia. So it's near to Thailand, Kedah, if you go heading upward. And then about the scholarship, about the postgraduate program. So for this moment in UiTM Penang under my department, so we are offering a course, a master by course class. So for this thing, I think that the students need to come register as a physical class lah. It's not it cannot be done in online class. And we are also offering a research program. So research program is under our main campus in Shah Alam, but the supervisor can be in branch campus. I mean that if you are willing to do postgraduate program, you can register under management of the main campus in Shah Alam. However, you can do a research in branches such as in UiTM Pulau Pinang. Okay, on the scholarship part, our university also offered some financial aid, such as what we call it here, graduate research assistant allowance. So for those supervisory or postgraduate students who do not have any scholarship, they can apply on the budget on GRA, so they can have some top-up money lah during their research activities. And all and the thing is that they need to if I can encourage to inform that get the scholarship from international organization and also from the local university itself or from the host university itself. So that's other way the scholarship can be given to the international student as well. So I think that all those informations I encourage to go to our main website here. For example, this one is our main site. You can see, am I sharing? Am I? Okay, I think, can you see this one? So this is our main website, UiTM Pulau Pinang. And later on, if you're looking for the informations about the postgraduate, I encourage go to the URL www.uitm.edu.my. So under section postgraduate. So these are the thing that we can offer. Sometimes the supervisor also has a grant. So that grant can be allocated to the supervisee if the student register under the same supervisor. So it will cover, for example, the yuran pengajian, study fee, kemudian tambahan-tambahan tu dia akan datang dengan some, as I said lah, additional financial aid offered by the postgraduate study office. Is the information enough, Mr. Dr. Mohairi?
Muhammad Muntaha.
Oh, sorry, Muhammad Muntaha. Sorry.
Yeah, maybe it's
Okay, thank you, Dr. Masyitah. I think enough.
Welcome.
Thank you.
All right.
okay. Please, I'm scrolling about the chat box and I found some question from the participant. Would you like to ask some this question before we end our webinar? The last question about our
Okay, if I can answer it.
The question is from Raditya Ahmad. He said, I have some question about ground improvement about the soil. First, what about the ground improvement if we have a case in a pit soil with 4 meters, especially what experience in Malaysia? Have you ever experienced about ground improvement with pit soil in 4 meters of the pit soil? And then for the second question, if in Malaysia road, is there cerucuk or cerucuk bambu or matras bambu have been used for the ground improvement about in road Malaysia? And for the third question is, what about the parameter of CPT can be used to alternative for correlation of the soil properties? It can be used from GPT. Sondir, like we call sondir in Indonesia. Yes, that is the 3 questions from Raditya Ahmad. Would you like to answer?
Okay.
Yes.
Thank you for the first questions. Honestly, my interest, I have not involved in the pit soil, and I know that the pit soil is a very problematic soil when you are dealing with. So that I couldn't answer more on that part, because I haven't dealt with the pit soil. But my suggestions to you is that pit soil is something that you can improve dengan cara you import the field, tu cara biasalah, ataupun you menggunakan what's our solution admixture untuk improve dia punya bearing capacity itulah. Kemudian berbalik kepada soalan nombor 2 berkaitan dengan bambu. Bambu as a reinforcement.
Yes.
Di Malaysia saya nampak dia punya trend ke arah menggunakan natural lah, macam sekarang ni menggunakan wood material in construction. So dia back balik pada zaman dulu kan. Zaman dulu kita buat bangunan semua guna kayu kan, kita tak guna sangat konkret lah kan zaman dulu-dulu. Tapi lah ni dia punya roda tu dia berputar balik, dia menggunakan natural. So banyaklah construction dekat London Mosque for example, dia dah menggunakan timber dalam pembinaan masjid dia untuk kubah lah, untuk kolom. Tapi untuk bamboo as a reinforcement, for this moment I haven't come across lagi menggunakan bambu tu untuk reinforcement material dalam soil stabilization ataupun soil improvement. Ada yang saya baca tu, dia dari segi biomass, sebab kita nak sustainable kan, banyak orang cuba kaedah yang lebih kepada bersifat natural sebenarnya. Jadi antaranya bambu lah kan. Dia ada efek dia yang kita kena tengok, bamboo properties tu, material properties tu. Bambu ni dia menghasilkan macam, dia bersifat manis kan, sweet sugar. So kita nak tengok the effect tu, kalau kata bila dia act as a reinforcement, dia punya reaction tu, material bamboo reactions dengan bertindak balas dengan mineral compositions of soil. Macam clay, kita ada different mineral compositions kan, montmorillite lah, mineral dalam clay itulah yang kita nak tengok kalau dia bertindak balas dengan bambu tu, macam mana dia punya impact kesan dia. So adalah saya come cross baca jugalah kan, bambu ni sebelum kita nak pergi further tu, we have to think out lah dia punya reaction, mineral reaction antara soil tu sendiri dengan bambu tu sendiri. Okay, on part of the last question CPT. CPT ni kita boleh correlate dia dari segi the strength of the soil lah untuk dapatkan bearing capacity of the soil, sama ada kita nak design untuk pile ke ataupun kita nak design untuk shallow. So dia ada correlations. This one pun dia depends on the project site lah. Tak banyak project site. Kalau dekat Malaysia pun masih lagi menggunakan SPT. Kalau pun yang paling simple, paling murah JKR probe test. CPT tu ada, tapi for this time I am not sorry, I am not sure, and saya pun tak boleh nak explain lebih lah on part of the CPT sebab my come cross is concern lebih kepada macam mana SPT kan, SPT value number tu dia guna pakai untuk design file lah. Itu saja. Terima kasih.
For connection about CPT, SPT.
Oh, CPT kan, SPT kan. The student asked CPT, right?
Yeah, CPT, right.
Cone penetration test. So
yes,
that's why I said when you are asking about CPT, dia bukannya tak ada. Ada. Cuma dia there are reason kenapa orang tak buat CPT kan.
More flexible using CPT for correlation, right?
Yes. Yeah, in terms of correlations, it's very easy use the CPT. Tapi tengok jugalah kan CPT ni dia boleh pergi ke berapa meter dalam. Kalau you buat SPT, kita boleh pergi sampai ke hard base of rock ataupun hard base of the soil kan. Kita dapat dia ni N number. So enough lah untuk kita nak design deep piling ke kan. So cantik kat situ lah SPT.
Yes. Okay. Thank you for answer all of the question, and I think it looks like we've covered all of our question, and it's time the end of our discussion webinar about geotechnical engineering. It's so interesting, and if I may to give some conclusion about this webinar, because maybe geotechnical engineering now can we use in the branches of the other engineering, right? Like structural engineering, mechanical engineering, and offshore engineering, and many more about that. And about the ground environment, now we can use and choose the sustainable properties to use in ground environment, like creativity about the soil stabilization, and about using the PVD, the other one, we have to use the ground environment and soil environment in sustainability for the world, not for in Malaysia only. I think we can use this discussion and this more research about sustainable geotechnic environment in Indonesia also. Right? Maybe this is the end of our webinar, and thank you for Mrs. Masyitah for a speaker in our webinar, and thank you for everyone and participant for joining us, and we hope to see you again in the next time webinar.
Thank you.
Yes, thank you. I give to the Master of Ceremony, Ayunda.
Well, thank you to Mrs. Fitria, and also Dr. Masyitah Md Nujid as the keynote speaker for being willing to fill out today's webinar. Previously, there will be a certificate submission which will be represented by Mrs. Fitria. The committee in DTIS can be helped by share screen.
Okay, Mrs. Masyitah, can you please stop the share screen? The committee will give some certificate as a speaker to you. Okay.
Thank you.
Yeah, this is the certificate of appreciation for Dr. Masyitah Md Nujid for being our international guest speaker in our webinar with the topic Sustainable Geotechnical Infrastructure Project in Malaysia. Thank you.
Thank you for having me again.
Yes, thank you.
Okay. Before we end today's webinar, let's take a photo. The audience may be able to uncam first. Okay, here we have the slide. So we'll take a photo per slide. We are going to start with the first slide. 1, 2, 3. The second slide. 1, 2, 3. Okay, here it is. Thank you for the committee on duty for helping us to take a documentation. Before going to the initiation, webinar participants who have not filled in attendance can fill in the attendance first, where the link is in the Zoom chat. Okay, Alhamdulillah, we have reached the end of the event. Thank you very much to the speaker, moderator, and participants who have listened to the event from beginning to end. Hopefully, a lot of knowledge going to be applied in everyday life. See you in the next webinar series.
See you. Thank you, participant. Thank you, committee, and thank you for Mrs. Masyitah.
Thank you all.